Hi everyone. We shall be ending air conditioning in this video. In the first video on air conditioning, we explained how a window unit works and how a split unit works. In the second video on air conditioning, we understood the working system of a VRV unit and a ductable AC system. In the third video on air conditioning, we learned in detail about chilled water air conditioning systems. Today, we shall study some special areas of air conditioning which need high level of sophisticated air conditioning. Areas like operation theatres and medicine factories where air filtration levels are extreme. Again, I repeat, we shall be understanding the concepts which help us plan our building layout better. Let's see the plan of an operation theatre, which is an average size required for any super specialty surgery. Let's focus on the operation theatre first. The air intake is exactly on top of the operating table, and the flow of air here is designed to fall vertically and then move away from the patient with a laminar flow system. Here, we will not go into the details of laminar flow, but it will suffice to show the movement of air from the patient in a very smooth flow. There is no turbulence in this flow as shown in the diagram on the right. The filtration is done by HEPA filters, which are high efficiency particulate air filters, so that the filtration levels are such that particles more than 0.3 micron are removed. And it is preferable that the housing for the filters is made from stainless steel 304. Now, in normal air conditioning, the return air is also from the ceiling, but in an OT, the return air is at the bottom of the walls all around. This return air, as shown in the figure, is guided from the bottom of the floor via a duct back to the AC indoor unit. It is basically a sealed system. In normal air conditioning, return air is not ducted back to the AHU. But yes, an OT needs fresh air. This fresh air is to be added in the system in the indoor unit to give at least 4 air changes per hour. Though this is designed by the HVAC consultants, but we should be aware that we have to make some arrangement to add fresh air. The position of entry of fresh air should not be planned next to contaminated zones such as DG set hoods, vehicle parking areas, etc. One very important point is that the air pressure in the OT is to be higher than the air pressure outside the OT. So, when the door opens, no air from outside can enter the OT. The OT is said to be under positive pressure. Again, this is designed by the HVAC consultant, but we as architects should be aware of it. Ideal temperature should be 21 degrees centigrade plus minus 3 degrees centigrade, and ideal humidity is to be 55%. This too is maintained by the HVAC consultants. One very important point is that even if the OT is not in use, the AHU blower will always be on, always, round the clock, but without the temperature control. And air changes can be reduced to 25% of operating hours. So only one air change is required per hour. Here we are not talking about other aspects of OTs such as finishes, etc. We are only discussing air conditioning. Now let's talk about air conditioning in a medicine factory. The levels of filtration are almost the same as required in OTs. But laminar floor is not required in all places. It is only required at places where testing of raw material is done. The factory we designed at Dhamola taught us a lot of things. Let's see the plan of this factory. It has very high level of entry controls for material and entry controls for personnel, and their movement is also very controlled. Air conditioning of each room has no relation with the other room because air of two areas should never get mixed. So when you have so many rooms to air condition with separate DX units, the best possible method is to keep the AHU right above that particular room. So when you have an AHU above each room, you need a complete floor for air conditioning equipment. Hence, a medicine factory, if the ground floor is the manufacturing area, then the first floor above it is used almost totally for air conditioning the ground floor. If we as architects are not aware of this system, then how will we be able to plan the factory? I think air conditioning is a vast subject, but we have covered up the basics. Each project will have new challenges. In each project, the discussions with HVAC consultants will lead to new solutions. But the basics we have discussed should help you be aware of the depth of planning required for HVAC. Hope these 4 videos have emphasized the importance of being aware about this subject, air conditioning. The 60 minutes you spent, 60 minutes, yes, the 60 minutes you spent to learn air conditioning will go a long way in helping you interns and freshers in your career. And that was exactly my motto. Do share and pass it on like I have done. Our next topic shall be waterproofing. Waterproofing for basements as well as terraces. And again, I assure you that in 30 to 40 minutes, we shall be able to explain the basics of waterproofing too. Till then, bye, take care.